All right, we started. So the lenses. First of all, we are going to learn about converging lenses. What does converging lenses mean? Converging lenses, they are basically convex lenses. Okay, we call them convex lenses. Normally, converging mirror was concave mirrors, but here, when we learn about converging lens, we are going to say what do you say? The convex lenses are converging lenses. As you see, one on the right, what does this mean? It means they are going to collect light rays into one place. For example, when these light rays come up parallel to the lens, it is going to come collect into that center behind the lens. For what is the difference between lens and the mirror? Lens, they can allow the light rays pass through them, but on the other hand, when you think about the mirrors do not allow the light rays pass through them. Okay, this is difference between them. As you see, when you send the rays, they are going to converge into one place. So we call them call this kind of lenses converging lenses. So the focal length is going to be half of the radius. So the radius means it is going to be from here, the pole of the lens to the center is going to equal the radius of the lens. The focal length is going to be half of it. Okay, the focal length will be half of the lens. There is a question. What? Ivona? What is the question? So this is the characteristic of the converging lenses. They collect the light rays. When we go to the diverging lenses, this time we're gonna call them concave lenses. Okay. So this time they are going to disperse. What does disperse mean? They are going to spread the light rays. They are not going to collect them, but they are going to spread them like this. As you see, normally, when you send the ray, normally for the convex lens, it is going to be around center. But when you send for concave lens, it is going to disperse the light rays. Okay, so they are diverging lens. As from the name you can remember, they diverge the light rays. Concave lens, on the other hand. Okay. All right, let's go to special rays. Special rays again, we learn these special rays for the mirrors. For the lenses, we are going to learn the same. When the rays come to parallel to the principal axis, it's going to be reflected over focus. Okay. When it comes from the focus, then it is going to be reflected parallel, right? When it comes from the center, it is going to go over center. Okay, when it comes from the center, it is going to be reflected on the center. When it comes from the focal point, it's going to go directly. It is not going to be reflected or refracted, doesn't matter. When it comes towards the like this, when it comes lens in any direction, then it will be reflected from the mirror. Okay, it is going to be reflected from the virtual focus. This was the converging lenses. What about for diverging lenses? For diverging lenses, if the ray comes to lens as parallel, these times we are going to see that it is like going to be reflected from the focal point, okay? And it's going to disperse. It's going to diverge like this when a parallel rays come to the diverging lens, okay? The second ray, when it comes through the focal like this, what's going to happen? Then the ray will be reflected parallel to the principal axis. Okay, it is going to be reflected parallel to the principal axis. The third special ray, if the ray comes to a lens as passing through the center, so what's going to happen? This time it is going to be again reflected like it's coming from the center. Okay, it's going to be reflected from the lens as it's coming from the other center of the lens. The fourth ray, if the ray comes the lens towards the pole, what's going to happen? This is the easiest part. It's going to go as it is, like it happens in the converging lenses. So diverging lens and converging lens has one common lens, which is has one common ray, which is when you send the ray through the pole. Okay. The fifth one, if the ray comes to lens in any way means like in any direction, what's going to happen to the light ray? So it will be refracted from the lens as coming from virtual focus. What does virtual focus means? From behind the lens, okay? Virtual focus. Here, the virtual focus. And then it's going to be reflected like this, okay? So to form an image, what we need? Again, we are going to need at least two rays from the same point. And they must be intersected after refraction, okay? If they don't intersect, that means we are not going to be able to have any image. So for converging lenses, they act like concave mirrors, okay? Converging lens, they act like concave mirrors. Remember, an object at the infinity, when you send the light rays to the concave mirror, the image would be formed at the focal point or focus point, at the focus. So the same thing is going to happen here for the lens. When an image stands at the infinity, when an object stands at the infinity, the reflection or the image of the object will be at the focus, okay? So what is the nature of the image? It's going to be inverted, diminished, that means smaller than the object, and it's going to be real because it is going to be behind lens. It is going to be real because the light rays are going to converge and make or produce this image. The second one object beyond C. What's going to happen? Now we are going to send a parallel ray. Again, parallel ray will be reflected over focus. Then we are going to send a ray through the focal point. Again, it's going to go directly. The point where these two merge, as you see, it's going to be between C and F. Our image will be there. So that means the image is going to be between C and F. It's going to be inverted, means like upside down. It is going to be diminished, that means smaller than the object, and it's going to be real because it is formed due to converging light rays, okay? What about when the object at C? When the object at C, again, we're going to send a parallel ray, which is going to be reflected over focal point, and then we're going to send a ray towards the focal, and then it's going to be reflected diagonally. It's not going to have any reflection. The point where these two meet is going to give us our image. As you see, it's going to be at the center. One object at the center, the image also will be at the center, but the only difference, the image will be inverted, okay? It is going to be inverted, the image, upside down. So it is going to be at C, inverted, same size as the object, and it's going to be real because of the converging rays over here. The rays are they intersect over here, and they make the image over here. What about if the object between C and F? Let's put it object, let's send a parallel ray. Again, it's going to be reflected over F. And then let's send a ray through the pole. And then they're going to meet over here. As you see, it's going to be beyond C. The image is going to be formed beyond C. You see image is inverted. The size of the image is greater than the size of the object. Okay? It's going to be magnified, we are going to call it. So it's bigger than the object. So we're going to call it magnified. Inverted means, again, upside down, and it's going to be a real image. What about object at F? What's going to happen this time? Again, we're going to send a parallel ray. When we send a parallel ray, it's going to be reflected over F, and then we're going to send a ray through the focal point. It's going to go straight. As you see, they are not going to merge. What does this mean? That means the image will be at the infinity. Okay, the image will be at the infinity. They are not going to merge, these two rays. So image will form at the infinity. And we cannot say anything about the characteristic of image because we are not going to see the image. Okay. What about the object between F and lens? What's going to happen? This time we're going to put the object over here. Again, send a parallel ray through the focal, and then send this ray. They didn't merge. What does this mean? We're going to then, this time we are going to take the reflection of the rays. Okay. And then our image will be behind the lens this time. It is going to be behind the lens, as you see over here, behind the image. So what is the characteristic of the image? It is going to be erect. That means not upside down. It's going to be straight up. Magnified, as you see, and it's going to be virtual because it's going to be behind the lens. Okay, it is going to be virtual, or as you see, the light rays, the shadow of light rays make an image over here. Okay, these are the characteristics of it. So why do we use them? Why do we use these converging lenses? We use them for magnifying glasses. for your eyeglasses, fixing farsightedness, okay? If you have like nearsightedness, we are going to use the concave lens. It's going to be diverging lens. But if you have farsighted problems, you are going to use convex lenses, like converging lenses, to fix your eyes, okay? This used in cameras and it used in microscopes. These are the usual where we use the converging lenses. What about diverging lenses? Let's go over diverging lenses. Again, diverging lens, whenever you send the light rays, it is going to disperse the light rays. They are not going to meet in anywhere, okay? So you're going to take their reflection and place where they meet is going to give you the image. As you see, the image is going to be in front of mirror. So it's going to be at F, okay? Behind the lens, virtual. Again, if it's behind the lens, this part is the behind the lens. Left part is the behind lens, okay? This part. This is the in front of lens, right? So what is the object is close enough to the lens? What's going to happen? As when we put the object beyond C, again, we are going to take the reflection of the lights. As you see, the reflection, where they meet is going to give us image. As you see, image is going to be between F and pole, okay? And it's going to be, again, erect, diminished, and virtual. So to summarize the diverging lenses, to summarize them, whenever they are located on the object side of the lens, we are going to have a virtual image always. We are going to have an upright image, means erect, and we are going to have a reduced in size, like diminished image, okay? Always. These are always going to happen. Don't forget that. And unlike converging lenses, diverging lenses always produce images that share this characteristic. Don't forget them. These three characteristics: virtual, upright, reduced in size. These three characteristics are always going to be for diverging lenses. Okay. For converging lenses, we cannot say they have exactly three characteristics. They have more than this. But for diverging lenses, this is going to happen. These three characteristic will always be there. Whenever the image, whatever you put the object, you are going to have this characteristic for the image. Okay. So what do you use them? We use for flashlights, for lasers, projectors. Remember, when you check the projectors, it diverges all the light around, right? Well, it comes from a small hole, but it diverges all the light to the smartboard that we use at school. So a projector usually diverging lenses, concave lenses we call it. So the glasses, again, the glasses, remember, we said the glasses for farsightedness, we use the converging lenses. For nearsightedness this time, as you see nearsightedness, we are going to use glasses, which are the concave lenses, okay? We are going to use this type of glasses.